Today we're going to go a little bit more in depth on photosynthesis. But before we can do that, we have to remember that the theme of this chapter is energy, and we've already talked about two kinds of energy. Kinetic energy is the energy of motion or usable energy to a cell, and potential energy is the energy of position or stored energy for a cell. In previous examples, we talked about a boulder sitting on a hill has a lot of potential energy, and a boulder rolling down a hill has a lot of kinetic energy. In terms of a cell, though, a cell would be using energy, that is kinetic energy, and storing energy, that is potential energy. Photosynthesis shows us how plant cells can change kinetic energy into potential energy. Because the sun has a lot of kinetic energy that can be used by living things for lots of things. Collected in solar panels and used to generate electricity, used to tan your skin. We can use it in a lot of different ways. The sun has a lot of kinetic energy. It creates waves and tides and all kinds of things. So it's got a ton of kinetic energy, and that energy is harnessed or captured by the chloroplasts, and the chloroplasts then use that energy to break apart carbon dioxide and water molecules and rearrange them into glucose molecules and oxygen molecules. Now the glucose molecule stores a lot of energy for the plant. So the kinetic energy in the sun is literally changed into the potential energy in a glucose molecule. Photosynthesis occurs in two steps: the light and the dark reactions. So the reactants don't go directly into the products. There's a couple of steps in between. And the light reactions is the first step, and obviously light is required for the light reactions to occur. Dark reactions is the second step. That can happen after the sun has set. So the plant is doing photosynthesis, the second step of it anyway, even after the sun has gone down. So the reactants don't go directly into products. That's why I've drawn the arrow like a staircase to show you the two steps that occur in photosynthesis. So let's look at the light reactions now. The light reactions, obviously the name implies, must have light. So the sun has to be shining, or a light has to be on in the room if it's a house plant, but light has to be available. The chloroplasts are capturing that light in their pigment chlorophyll. And energy from the sun is absorbed and used to break apart carbon dioxide and water. And that's really the first step, is breaking those reactants apart. That's all that's happening in the light reactions. The energy from the sun is breaking apart carbon dioxide and water. The dark reactions can occur with or without light. So they happen during the day, and they continue on after the sun has set. And here what's happening is the glucose is being put together, and the leftover oxygen is made into O2 molecules and released as a waste product. So the dark reactions basically is the step of putting together. So first you break apart the reactants, then you put together the products. That's all that photosynthesis is. And the two steps are called the light and the dark reactions.